Thank you so much for supporting this channel. I've been seeing the growth on this channel. It's been amazing. It's been a long wait, but here we are. A few things are changing this year. So I have gone ahead to create a GitHub page for the BIM Mentor. And this is where I will be uploading select code from our videos. And this is because some of this code I intend to use for other purposes. I don't intend to make them open. And I have, first of all, created a support page on my GitHub. So this is where I have put boilerplate code essentially for C# because I got some comments about how difficult it is to remember all the steps. And I think the videos are going to be a bit long and boring if I have to go through each one every single time. So I've created this page. I'll be adding it in the video description. This is boilerplate code just to get you started with your Revit Addin. Instructions for how to start when you install Visual Studio. And also how to create your manifest file. So there will be basically a manifest file that you could copy and paste and replace all of the information, and a boilerplate for your actual code. Now, when you start your class, you're going to see a couple of using statements, but it's always good to have these as well, just to make the code run for most Revit applications. All right, so today we're going to make an add-in that lets us create elevations from room. This is my add-in in motion, and when I click on my room, it generates an interior elevation view, which is named after the room. I called it BIM room, which is sort of redundant, room, BIM room. We'll make a smarter name in the future. But this is the add-in we're making today, and we're going to hop into Visual Studio to see how to make this. Let's get started. Before we continue, today's video is going to be a little different. We're going to be installing something called the Revit Addin Manager. Now, a quick Google search of the Revit Addin Manager, and you would get a result possibly similar to this. This is the one we want, the one from Chong MEP. Now, why do we want this? In the past, if we needed to debug our code, we'd have to go through this long process of launching Revit from within Visual Studio. This is one of the instructions in the support page about how to essentially put your Revit program to start when you debug. Yeah, we're going to skip this step this time around. And the reason we want to do this is because, well, Revit is slow to start up. I don't know how good your computer is, but it's a little slow. And it takes too much time to close Revit and launch Revit again each time we want to test our code. So we're going to be skipping that by installing the Revit Addin Manager. So if you go into this link here from Chong MEP, you are likely to see this page. This is the GitHub page. And what we want to do is scroll all the way down to where it says installation and how to install Addin Manager. When you click on this, it takes you to a page where you can download the latest MSI, which is in this link called last release. Click on that. It takes you to the MSI. You could also download the zip file if you want to copy the file manually, and there will be instructions on how to do that, but we're not going to show that in this video. So if you click on MSI, it downloads, and you can run through the installation steps like any typical installation. This is what it looks like. So if you want a visual guide, this is how your installation would look with next, install, and finish. That's it. Once that's done, come back to me in Revit and let's continue coding. One of the things to note for later, since we're using the Addin Manager, is where this app is going to be built to. We are basically building the app to our add-ins folder. So it's Autodesk Revit Add-ins 2023. It's your app data folder in your users page. Okay, so first up, let's right click on our project name, which in this case for me, it's the BIM Mentor. And this is the project I'll be using for all my videos moving forward. Right click and add new item. What we want is a class, and I'm going to call that class create elevation. That's it. I'll say add. There's my class. And I guess this is not a bad time to also just make our add-in file while we're at it. And I'll right click again and I'll say add new item, and I will look for an application manifest file. And remember that we want it to be .addin and not .manifest. So I'll just give it the same name as my project name because the manifest file can host several classes, but usually only for one project. So it will be the BIM mentor .addin. Now I've broken several rules of naming here. Please don't go ahead to keep naming things in this way. I've already talked about naming conventions in my other video, but we're just hobbyist programmers. Let's just have fun. I'll click on add, and we want to delete all of this and go and copy what I put in the GitHub page as the boilerplate code. So we go back to here, manifest file, and you could just copy here, basically, and paste it. That's all. And in the actual class, we're going to also just get rid of all this and go back to the support page, look for the boilerplate, just copy it and paste it. Good. Well, we don't want this. So let's get rid of this comment, just make our code look neat. I'm keeping all the system collection and system link things because we also need that as well. So first thing to change, the namespace is supposed to be your project name, which is the BIM mentor in this case. And then we will go ahead to change the class name to our actual class name, which is create elevation. Good, we're almost there. Okay, so let's quickly just rearrange our project space so we can actually see our code, and let's get started. Let's take a look at some of the classes that we'll be using in today's code. So in Revit, if you have a typical rectangular room, for example, you first need to select the room. To do this, you need to add a selection filter, which will sort of gray out everything else in Revit and only highlight rooms for you to select. And then you need to actually call on a reference that will let you click on the room object. Now, once you've clicked on that room object, you need to store it somewhere. When you're doing things from the front end, you sort of just click and things happen. But when you're coding, you need to always have a container for everything that you create. So clicking on that room needs to be stored somewhere, which we'll later use to find the center point of the room. This is what will form the elevation marker. Now, the elevation marker on its own comes from a family type, right? It comes in a Revit family type, and then it has these 4 markers around. So there's north, east, south, and west. It's sort of clockwise. Please don't judge my sketches, even though I'm an architect. And this sort of going a clockwise index as well from 0, 1, 2, and 3. And then we also need a class that will actually create the view. So all you've done now is generate the family type for the elevation and add 4 markers around it. But this doesn't actually generate a view when you're coding. So you need to add an additional class, and it's called the view section class. You can think of it as that blue line when you click on an elevation marker in Revit that shows up and actually forms the view. So this is a view section class. The reason it's a view section class and not a view elevation class is because if you come here to the Revit API docs, if you scroll down to the end, you notice all the hierarchy of inheritance for the view class, and you see view 3D, view drafting, view plan, view section, view sheet, but you don't see view elevation. So you can create all of these, but not an elevation. However, the best way to do this if you're coding in the backend is to basically implement a view section into your elevation marker, and that's how you generate, in quotes, an elevation view. You can do more research on this. I know there's articles about this on the Building Coder website, but that's essentially what we're going to be doing today. And just to summarize, if you're more interested in looking at the classes in detail, the room class is over here, and you can see some of the methods we'll be calling today, like the name method, the reference class, which lets you create a reference from our selection, the iSelection filter that needs us to return an allow element and allow reference method, the view class, which we'll be using to generate the section, or in this case, elevation, the view family type class, which we'll be using to call on the elevation itself, and the elevation marker, which will form the north, east, south, and west elevation. Because it goes clockwise, it's northeast, southwest instead of north, south, east, and west like we're used to. Okay, now that we know all the classes, we can start coding. So the first thing we do here is to get rid of this comment right before return result.succeeded. And what we want to do is we want to create a transaction that will change the state of our model. Like I explained before, the only way to change a Revit model is to actually encapsulate your code in a transaction. And to avoid any heartbreak, we're wrapping that transaction in a try-catch statement. If you don't do this and there's any errors in your code, you're going to be dealing with a crash. And depending on how much work you've done, that's very undesirable. So first thing we want to do is create a try-catch statement with the syntax try curly braces and catch curly braces. For the sake of speed, I'm going to be relying a lot on IntelliSense in this video. Please don't judge me if you're a professional. This video is targeted at beginners, so I hope that you can forgive my typos and just trusting in IntelliSense throughout this video. Right, so now that we have our try-catch statement, we're going to be adding the remaining part of the try-catch statement, which is the exception handler, into the catch part, and we'll just call that exception EX so that we can reference a message later on. And we will return in the catch statement a message to the viewer that just says, oh, this is what happened. And it will just be referencing the message method from the exception. Right, so this will handle any mistakes in our work. And this will be basically the successful portion, or the portion we want to work. The other thing we're going to be doing today is getting a room element. So obviously you need to access the document for this. I explained what the difference between UI app, UI doc, and doc is in my earlier videos if you're not too sure what this is about. And to do that, we will be referencing the get element method from the document. Now that that's done, we want to implement this method, and it's asking for the element ID. However, this is not the approach we'll be taking because we don't want to always have to know the ID of our room before we get it. We want to just click on it, and so for that we'll be using a reference. Since it hasn't been created yet, I'm just going to put the variable name in there and call it room reference and return it as a room. The reason we do this in C# is because sometimes the data type that comes out of something is not the data type that we want to use. In this case, we're trying to get the room name, get the room center point, and what get element is returning is just an element class, but we want it to return a room class. So we're casting it as a room so that it gives us a room class in the end. And it's red because it should be encapsulated in a variable. So let's create that variable. So we first declare our variables as usual, call it room, and make it equal to that. And now this is red because this reference doesn't actually exist. So let's go right above our room and make that reference. So what we want to do here is declare our variable room reference. And this room reference is based on a selection that we make. So we are going to be accessing the UI doc in this case and selection method. This will then let us access the pick object method. And this is how you would usually select elements in Revit. And this all requires an object type, which in this case is an element, an iSelection filter, which we haven't made yet and we'll be making subsequently, and a string. This is the message that displays at the bottom of Revit when your command is active. So let's go in first and say the object type will be object type, and we'll be accessing the element method for this to fulfill the requirement. And the selection filter, we'll make a new one. It hasn't been made yet, but let's just make a new one called room selection filter. This will help the IntelliSense sort of start that process for us. And then the message, the string will be select, in this case, your best room, so that we can see that control that we have. Awesome. And then I'm going to end it in semicolon as expected. Now this is red because it doesn't exist. I'm going to say control full stop just to implement that on the PC. And it's asking me to generate the class, but it's asking me to create an internal class. That's not exactly what I want. I just want it to be a public class outside of the iExternal command, also so that I can refer to it in other code if I need to. So I'm just going to come underneath the iExternal command. Similar to the iExternal command, this is an interface. So it's going to be public class, and then the name of the filter, which is room selection filter. And just like iExternal command, we access it with a colon and then iSelection filter. So I'm tabbing to implement that, and I need to close it. And I'm just going to implement explicitly the way we do for the iExternal command here. So control full stop, implement interface, and now I have all the requirements of the interface. Because we are working with an element now, we've already declared our reference to start with. We are just going to say we don't want to be able to select a reference. We want to be able to just select the element. If we allow the reference, it means other things will be open for selection in Revit, and that's just a bit confusing. So we'll say return elem, which is the element here, is room. So let me select a room. That's basically what this means. And the allow reference should just return false because we don't necessarily need one. Okay, now that that is done, we have our selection filter. This is no longer a squiggly line. Right, so now that we have our room selection filter, the next thing we want to do is get the center of our room, because that's what will be informing the elevation marker. So to do that, we need to get the room's location and store it as a point. So let's declare a new variable called location point. And let's just call it room location. You could call it room lock or lock point or whatever works. And let's access the location method of the room and cast it back as a location point so that it stores the right data type. And using this, we'll get an XYZ variable that will store the exact point as an XYZ. So XYZ, we'll call it in this case room center. This is going to inform the actual elevation because we want it placed smack in the center of the room. And we will access room location and access the point method. Awesome. So following our tutorial on how to create a transaction, we'll start off with a using statement. And transaction, let's call it TX equals new because it's been instantiated for the first time. Transaction. So we access the document and we'll say create room views. Perfect. The next thing we want to do is to create our curly brackets and say transaction start. And once it starts what we want it to do, we are going to create a helper method, but let's just call it create room elevation views. You could name this simpler if you wish. And for this, we'll be accessing the document, the room, and the room center. And then we will commit that transaction. We also want to return a dialog once this is successful. So we'll create a dialog right now, text dialog.show, and it will return a message that the views were created successfully. And let's leave a main instruction and call it room view creation. So now all that's left to do is to actually generate the helper method that we have described here. So I'm just going to do control full stop as always on PC, and it will just help me generate the initial structure for my method. I don't want it to throw a exception, so I'm just going to clear this out and start defining how I actually want the method to work. Remember, it's already wrapped in our transaction, so this is the portion that controls Revit. This is the portion that just tells the transaction what do we want it to do. So first of all, we want to locate the first available view family type for an elevation. So that's literally the Revit family. And to do that, we need to go through a filtered element collector and go through the whole document and find the first elevation family type we can find. So we start by creating a view family type variable. And let's just call this elevation type. And we'll set it to null because we're going to use a for statement later on to populate it with an actual elevation type. Just fix this typo. Great. And then we want to use a enumerable interface, an IEnumerable, which is kind of like a list, but it's a list that you don't edit. You don't check the length or rearrange the list. It's kind of like a fixed list, to put it simply. So we access the IEnumerable. And in this case, it's going to be a enumerable of view family type. And let's call this, view family types. Now from here, we want to set this to a new filtered element collector. And this will pass through the whole document and find the class. So we'll say of class, which is a view family type. But obviously this won't work because there's not really such a thing. So what we want to do is wrap it in a type of statement. And then cast it back to a view family type object. Long and short of this is we're trying to filter through the document to get a view family type, and because of the different data formats in the Revit API, you have to first retrieve the class and then cast it back. Otherwise, it's just not returning the right data type. The next thing we want to do is create a for loop. So we'll say for each view family type, and we'll call this view family type VFT for the sake of simplicity. In our collection of view family types, go through this whole list, this whole collection. If the view family is equal to an elevation, so if the family you're returning is an elevation, then make it our elevation type. So just make the elevation type VFT. Just fix this typo here real quick. And once that's done, just break. Don't keep searching. Don't keep doing anything. Just end it there. Break. Perfect. So this will search through and assign the first view family that is an elevation to our view family type. Then once we have that, the next thing we want to do is add the 4 elevation markers. So we say elevation marker, and in this case, we'll call it marker. And let's just create one by accessing the create elevation marker method from elevation marker. And then let's provide all the information that it requires, which is the doc, the element ID, the XYZ data type, and the scale. So that's the initial scale of the view that is generated by the elevation marker. So we'll call this doc to start with. For the ID, let's get the ID from our elevation type. So we access the ID method. The XYZ point is the room center that we already created before. And you can set the scale to 1, but I'm going to set it to 100 just so you could see that it sets the scale to 100. The other thing we will do now is to, following the elevation marker, create 4 markers. So actually add those arrows and then generate a view using the view section. And then name them based on the name of the room. So call it like room north elevation, room south elevation, room east elevation, that sort of thing. So to do this, let's start with an empty list. And it's going to be a list of strings. And we'll call this list of string directions. And since it's new, we always have to use the new keyword. There's a bit of repetition in C#, just go with it. And then we will store this in a list, but we'll use curly brackets in this case. So I'm just going in the clockwise direction. So it's north, east, south, and then west. This is because when it's iterating, that's how it's going to move. And we'll end this in semicolon. And now we want a for loop. I'm missing a quotation mark here. I think that should fix it. Another one here as well. Good. All of the errors are gone. This is also the wrong syntax, so I'm changing that to a capital. Great. I'm not exactly looking while I type, so just ignore any red lines you see until I'm done typing. Okay. Now that we have that list, we're going to iterate through and use a for loop. So for int I equals 0, so that's where I is 0, I is less than the length of our list of strings, so that's 4. So I is less than 4 essentially, but because we just want to keep it controlled, instead of saying I is less than 4, we'll say I is directions.count. That's the length of that list. And I plus plus, meaning I is incrementing by 1, so it's 0 and then 1 and then 2 and then 3, that sort of thing. While this is active, go in and instantiate a view section, which in this case we're calling elevation, and using the marker, create an elevation. So access the create elevation method and do this using the doc, the active view, which is doc.activeView.id. Not sure how project location got there, but okay. And then I, which in this case is our index. And that should be it. This is the wrong way to spell ID, hence the red line. Fixed it. And then after you've generated the actual view from the view section class, name those views by accessing elevation.name. And first, this is a concatenation, so we're accessing methods and also strings here. So some of them are deriving from basically other classes, and some of them are just pure strings. So the first part is the room name, which we're getting from the actual room itself in Revit. So we'll access the name method. The next part is the underscore. You don't necessarily need one, but I always like to separate fields in my naming with underscore. And then because we're already in a for loop, you can use I to access north, east, south, and west. So we're going to access that list of strings and say index I. So it will go through each index one after the other and return north, east, south, and west. And then finally add elevation as a string. Great. And end this all in a semicolon. Good. Our code looks good, guys. So we have our helper method that will sort through the whole model, get us the first view family type, and then using that, create a bunch of elevation markers in 4 directions, and then name those elevations with the room name and underscore the direction of the room ending in elevation. I think that's all we need, and we don't have any errors, so it looks like the code is ready to go. One last thing I will say is that we should clean up our Addin manifest file just to make sure. So we'll call this the BIM mentor, which is our project name. We'll call this the project's ID. So you go to tools, create GUID, just copy the GUID and paste. And then call this the BIM mentor. And call this the class name, which is create elevation. And you could describe the command if you want. I'll just say create room elevations. I'll call the vendor ID the BIM mentor, or the BIM just for short. Details, coding for fun. Okay, now that we have that, save all. And instead of debug, we're just going to build. We're building the solution in this case just because we are actually going to use the Addin manager. Okay, now that that's done, we will go into Revit. And now we're going to look for the Addins tab, Addin manager, manual mode. And here we want to load the app that we just created. So you click on load and you want to sort of navigate right back to that folder where your app is being built to, which of course you could change the path if you want, but this way it just loads directly into Revit when you launch it typically. And that would be the add-ins folder. And we'd click on 2023 because that's where we, built it to. And this is it, the BIMmentor.dll. You click on the DLL file. This way, whenever we make any updates to our code, because we're going to keep building more things to this BIMmentor.dll, it's just going to show up in the Addin manager. We don't have to first do a debug, then launch Revit, then wait, and all that, time-taking process. We could just trust in the Addin manager. Okay, so now that it's loaded, click on it, say run. And you can see everything's grayed out because we put an eye selection filter, and it's not letting me click on any walls because I created an eye selection filter. But I'm just going to escape real quick. I want to rename this room number to 11 just so that we can see that it's actually picking the number and the name, and name this to best room. Good. So I'll go back to Addin manager, manual mode, click my Addin, run, and you can see the message is giving me select your best room. This is the message that we created. And if I click on this, you can see it's made first the elevation marker based on the center point of the room, then the 4 elevations north, east, south, west. Then it's actually named those views based on my room name and room number and the direction of the room. That was in the last string that we concatenated. So now you can see your adding is working. If you like it, you can go ahead and create a full tab for it based on this video in the top right hand corner, or you can just keep following our videos as we build more tools and then we eventually turn them into a full-fledged application. There you have it, the script's working. Oh, by the way, did you subscribe?